Molecular cloud. Every star that has ever existed began inside one of these. They are enormous regions of cold gas, mostly hydrogen bound into molecules, held at temperatures only a few degrees above absolute zero. Dust mixed through the gas makes them almost completely opaque. So, in visible light, they show up as blank patches where the background stars simply stop. The Taurus molecular cloud, about 430 light-years away, is the closest one to us. The Orion complex is far larger, stretching across hundreds of light-years. Nothing inside them glows. Radio and infrared telescopes are what revealed their structure, because those wavelengths pass through dust that blocks visible light entirely. Bok globule. Some dark clouds are small, round, and unusually dense, and those are given their own name. The astronomer Bart Bok proposed in the 1940s that these compact clouds were cocoons with stars forming inside them. He was right, though it took decades and infrared instruments to prove it. Barnard 68, about 400 light-years away in Ophiuchus, is the textbook example. In visible light, it is a solid black patch punched into a rich star field. Photographed in infrared, dozens of background stars appear straight through it. The cloud itself never changed. Only the wavelength did. H2 region. When massive young stars switch on inside a cloud, their ultraviolet light strips electrons away from the surrounding hydrogen atoms. Astronomers call that ionized hydrogen H2, and a large volume of it is an H2 region. These are the visible face of star formation. The Carina Nebula, around 7,500 light-years away, holds several of the most massive stars known. The Tarantula Nebula sits in the large Magellanic Cloud outside our own galaxy, and remains the largest star-forming region found anywhere in our local group. The gas is being lit and eroded by the same stars it produced. Emission Nebula. This is the broader category that H2 regions belong to, covering any nebula producing its own light, rather than reflecting someone else's. The mechanism is the same. Ultraviolet radiation knocks electrons free. The electrons fall back into place, and each time one does, it releases light at a fixed wavelength. Hydrogen releases most of its light at 656 nanometers, deep in the red, which is why so many of these clouds photograph red. The Orion Nebula is the nearest large example, about 1,300 light-years away, and it is bright enough to see without a telescope as a smudge in Orion's sword. Reflection Nebula. Not every glowing cloud is generating its own light. Where a nearby star is bright but not hot enough to ionize the gas around it, dust grains scatter the starlight back toward us instead. Those clouds come out blue, and the reason is the same one that makes Earth's sky blue. Shorter blue wavelengths scatter more easily off small particles than longer red ones do. The Witchhead Nebula is lit this way by the star Rigel, and the Pleiades cluster sits inside a veil of dust that scatters its star's light into a faint blue haze. No new light is being made here. It is only being redirected. Dark Nebula. Take the same dust and put nothing bright behind it, and it stops being a feature and becomes an absence. Dark nebulae are dense clouds identified purely by what they block. The Horsehead, catalogued as Barnard 33, is the best known one, and it is only visible because a bright emission nebula happens to lie directly behind it. Without that backlight, it would be invisible. It was first recorded on a photographic plate at Harvard in 1888. Photographed in infrared, the horse shape softens and partly dissolves, because infrared passes through much of the dust that blocks the visible view. Proplyd. Inside the Orion Nebula, Hubble found small dark disks silhouetted against the glowing gas behind them, each one wrapped around a newly formed star. The name is a contraction of protoplanetary disk. These are solar systems in the middle of assembly, the flattened disks of gas and dust from which planets condense. Being embedded in an H2 region is hard on them. Radiation from the massive stars nearby boils material off their outer edges, which is why many of them trail teardrop-shaped tails pointing away from the brightest stars. Some will finish forming planets, others will be stripped before they get the chance. Herbig-Haro object. A forming star does not only pull material inward, it also fires narrow jets of gas outward along its rotation axis at hundreds of kilometers per second, and where those jets slam into slower surrounding gas, the collision heats it until it glows. Those glowing knots are Herbig-Haro objects, named for George Herbig and Guillermo Haro, who studied them in the 1950s. The phase lasts roughly 100,000 years, brief enough that these are the clearest sign of a star being born right now. Hubble photographed several of them repeatedly between 1994 and 2007, and those images can be played in sequence to show the gas physically moving. Cometary nebula. A small group of reflection nebulae take a fan or wedge shape, bright and narrow at one end, spreading out at the other. Nothing about them involves an actual comet. The shape comes from a young star sitting at the point of the fan, lighting a cone of dust in front of it. The clearest example is NGC2-261 in Monoceros. Edwin Hubble studied it in 1916, and it later carried his name because the nebula visibly changes shape over a matter of weeks. Dust close to the star drifts across its light and throws moving shadows across the cone. It was also the first object photographed by the 200-inch telescope at Palomar in 1949. Pre-planetary nebula. When a star like the Sun runs out of fuel, it swells, becomes unstable, and sheds its outer layers. For a short window after that, the exposed core is not yet hot enough to make the ejected shell glow. So the shell shows up only by reflected light. The Boomerang Nebula, roughly 5,000 light-years away in Centaurus, is the strangest one found so far. Its gas is expanding fast enough that it has cooled to 272 degrees below 0 Celsius, 1 degree above absolute zero. That is colder than the leftover heat of the Big Bang, which sits at about 270 below. It remains the only object known to be colder than the background temperature of space itself. Planetary nebula. Once the exposed core gets hot enough, its ultraviolet output ionizes the shell it just threw off, and the whole structure lights up. William Herschel gave these objects their name in the 1780s, because through the telescopes of the period they resembled the small round disks of planets. The name stuck and has confused people ever since. There are no planets involved. The Ring Nebula and the Helix Nebula are the two most photographed examples. The Helix lying only about 650 light-years away. This stage is short. A planetary nebula disperses within tens of thousands of years, leaving the white dwarf core behind. Bipolar nebula. Many of these dying shells are not round at all. They form two lobes on opposite sides of the star, pinched at the waist into an hourglass. A thick ring of dust around the star's equator is what does it, blocking the outflow sideways and forcing it out through the poles instead. A hidden companion star can produce the same effect. The Butterfly Nebula, about 3,800 light-years away in Scorpius, spans more than 2 light-years and was expelled over roughly 2,200 years. Its central star sits hidden inside that dust ring, with a surface temperature above 220,000 degrees Celsius, which makes it one of the hottest stars known in the galaxy. Wolf-Rayet Nebula. Stars far heavier than the Sun end differently. Some pass through a brief Wolf-Rayet phase in which they blow off their outer layers in violent, uneven bursts, building a shell around themselves before they explode. WR-124, 15,000 light-years away in the constellation Sagitta, is the clearest example available. The star carries around 30 times the Sun's mass and has already shed the equivalent of 10 suns. The nebula around it now spans 10 light-years, and its structure is lumpy rather than smooth, because the material came off in irregular episodes rather than a steady wind. The supernova is still ahead of it. Supernova remnant. After the explosion, the debris keeps traveling outward for thousands of years, and it stays visible the entire time. Shock waves heat the gas, magnetic fields thread through it, and the whole structure expands into the surrounding interstellar medium. The Crab Nebula is the reference case, because the explosion that produced it was recorded by astronomers on Earth in 1054, which means its age is known rather than estimated. At the center sits the collapsed core of the original star, now a neutron star, spinning about 30 times a second. Remnants like this are how heavy elements forged inside stars get returned to the galaxy. Light echo. The last one is not a cloud in the usual sense at all. In January 2002, the star V838 Monocerotis brightened suddenly, and the flash spread outward through dust that had been sitting around it, unlit for a long time. As the light reached each layer, that layer lit up and then went dark again behind it. Hubble photographed the object repeatedly through 2006 and played in sequence. The images show what looks like an expanding shell. Nothing is expanding. The dust is stationary. What moves is the light, and because of the geometry involved, the pattern can appear to spread faster than light travels, which nothing is actually doing.